let's look at 818. Water treatment plant process 21,000 meter cube of water per day. This is the flow. Assume two types of flocculated particles enter the rectangular sedimentation basin. So there's two types of flocculated particles enter the rectangular sedimentation basin that has a dimension: depth, width, and length. This is the sedimentation basin or the tank. The first type of particle has a settling velocity of 0.5 meter per hour. The other type has a settling velocity of 1.8 meter per hour. What percent of particles are removed for each of the two types of particles? Well, for these type of problems, we have to find, first of all, the overflow rate, or V critical. Beyond that, we could compare it with the settling velocity of each one of them and find out which one of them will be removed and what is the percentage of the removal. So let's find OR, V critical, Q over A. $21,000 over the area of the basin. It is a depth. We will not use the depth as the area. This is for the volume. We use only the width and the length. Okay, so don't make this mistake. It's 6 times 40 meters square. The 21,000 is meter cube per day. So right now, since here the velocity is in hour, we could convert D, the day, into hours. 1 day is 24 hours. So day with day, and you'll end up with meter cube per meter square per hour. So this is 3.7 meter cube per meter square per hour. Now, let's look at the first particle, the 0.5 meter per hour. Okay, and let's see if it is. So the first one, the 0.5 meter per hour, the first particles, is less than the V critical. This is the V critical, the overflow rate. It's less than the 3.7 meter cubic per meter square per hour, which is the same unit. So the percentage removal is calculated as this. Percentage removal of the first particle, it's equal the settling velocity of that particle over the overflow rate, or the V critical. So this is 0.5 meter per hour over 3.7 meter per hour, and that would give you 0.14, which means it's 14% removal, because the settling velocity is smaller than the V critical. Let's look at the next particle. The next particle has a settling velocity of 1.8 meter per hour. It's still less than 3.7 meter cube per meter square per hour. But let's find out the percentage removal. The percentage removal of the second particle, it's equal Vs 1.8 over 3.7. The critical velocity is for both, and that would give you 0.49, which means 49% of particle number 2 will be removed, will be sedimented at the bottom of the tank, while the rest will be still suspended. Here's 14%. Okay, so that is the answer of this. I guess there is what percent of part. That's it.